Hello and welcome to my video. This problem right here actually looks like a joke problem at first, which just looks ridiculous. But I think this problem actually contains a lot of important properties of logarithms, including the very definition of the logarithm and how the logarithm extracts the exponents and the base changing formula for logarithms. So let's dive into the problem. So we have to simplify this expression. First, let's take a look at this first term. The definition of a log is when a to the power of x equals b, then we write x as log base a of b. So if we replace this b with a to the power of x, we have x equals log base a of a to the power of x, which is the basic function of the log. It extracts the exponent. Therefore, this first term is, so here we have log base n, so this exponent part is extracted, so we have n to the n here. And next, this exponent is extracted, so we have n here. Therefore, we have log base n of n, which is simply 1. So this entire first term is 1. Now let's take a look at this second term. So we have to simplify this expression. But how can we simplify the inner logarithm, log base n to the n of n to the n to the n? Well, some might say it is just n because this exponent part is extracted, but that is just wrong. Because remember, this power tower should be calculated from top to bottom, or some people say from right to left. That is, for example, 3 to the power of 3 to the power of 3 means 3 to the power of this entire thing, so it is 3 to the power of 27, and it is not equal to this. So similarly in here, this part means log base n to the n of n to the power of this entire thing. So here we instead use the base changing formula, where we can introduce a new base k according to this relation. So here for this part, instead of using the base n to the n, let's use base n. Then, using this new base n, at the denominator, we have this part, so we have n to the n. And in the numerator, we have this part, so we have n to the n to the n. Therefore, in the denominator, this exponent is being extracted, so we have n as the denominator. And in the numerator, this exponent is extracted, so we have n to the n. Therefore, we have n to the n minus 1. And that was for this part. So the entire second term is log base n of n to the power of n minus 1. So therefore, it is n minus 1. So therefore, for this second term, it is n minus 1. So the first term is 1, and the second term is n minus 1. So our final answer is 1 plus n minus 1, which is n. And this is our final answer. And that was all for today's video. Thank you for watching, and I will see you in another video.